Hello, everyone, and welcome to Inflectra's webinar called Scenarios or Why Some Automation Projects Fail. First off, let me introduce our today's speaker. Today, we will be talking with Alexey Grinevich, a senior software developer here at Inflectra. He holds a doctorate degree in applied mathematics and has been working in the IT sector for about 20 years. For the last 10 years, he's been focusing on automation testing, as well as legacy APIs and desktop system testing. My name is Taya. You've seen me before, I assume, and I will be your moderator today. Now, while we wait for other people to join us, let's go over our usual housekeeping. Today's webinar will be about 45 minutes as usual and will be followed by a Q&A session. Please save your questions until that time, and please use a built-in questions tab in GoToWebinar to send questions. We will answer those questions during the Q&A session. Today's webinar will be recorded like we do every time, and in a couple of days we will make the webinar recording available on Inflectra's YouTube channel. We usually use a playlist called Test Automation Demystified for this purpose. Please note that the webinar playlist is quote-unquote unlisted for the duration of the webinar series. You will need to have a direct link to access the recording of the webinar series. This link will be emailed to you in a couple of days after today. You can subscribe to Inflectra's YouTube channel to get notified about our new webinar recordings, or just wait for that email to arrive. For those joining us for the first time, I would like to recap the key aspects of the whole series. So today's webinar, as you know, is the 6th webinar in the series called Test Automation Demystified. And this series is the level 1 or introductory set of webinar series in test automation. With this webinar series, our goal was to help new or inspiring software testers to get a better sense of what's involved in test automation. You can learn more about the series by clicking on the URL shown in your handouts, and then there are other interesting links there as well. One of the other things about Test Automation Demystified series is that it's a certificate course. The series participants are eligible to receive a certificate of completion. However, there are some rules and requirements, such as a short quiz to be taken after each webinar. All this information is also available in the handouts. Last but not least, please note that each webinar in this series has a part in which we demonstrate the practical aspects of the webinar via our own test automation tool called Rapise. Rapise is available on our website, and the address is www.inflectra.com/Rapise. If you haven't had time to check it out, this is your opportunity to do so. Please go ahead and sign up for a 30-day free trial. This is all that I wanted to tell you today, and without much further ado, I would like to hand it over to Alexey.
Thank you, Tia. Can you hear me?
Yes, we can hear you.
Okay, great. So my name is Alexey. My info is here. Tia already told about me. So let's go on. Let's begin. So today we are going to talk about test automation as a project. When you have an application, you need to build a test framework, you need to embed it into some kind of continuous integration, or you need to achieve some characteristics like quick delivery or validation or whatever your application requires. So how to do, how to start, where to look at, what to afraid, what to avoid. This is what we are going to talk about. So what happens if we look at available theoretical articles or books about test automation efficiency? Probably you have seen the graph like the one displayed on the screen. So I just took it from the internet as the first one that I've found. It's very typical. So it's declared that there is manual testing, which is displayed in red color, and compared to it, automated test, which is displayed in green color, has beginning part which would require higher costs when you develop your automation tests, but then it keeps some context cost to execute test cases compared to manual testing, which requires more cost to execute. So the difference between red and green is your saving. So this is what you going to expect from test automation. If you Google more and look at other graphs, you may find that there are more fine-grained pictures actually showing the same process. So again, this is the same process, but with some more details. They again tell that this dashed line is automation. Here is your investment, which is higher in the beginning than investment into manual testing, which is red in this case. But then it becomes more or less constant or grows slowly, while manual testing keeps eating permanent efforts for each iteration, for each period of time. So after some time in this area, you're starting to save your effort. The difference between this red line and blue line is your saving. But one thing that appears to be a bit dangerous, and this is what causing a precaution, is how this graph behaves. You see, it's curved and it starts to grow in this area. What does it mean? What if it starts growing more? And again, this is one more graph, again from Googling for images about test automation. You see, blue is like metaphorical ideal test automation project. So you developed it once and it runs forever. It's doing testing every time. You do nothing. You get your product tested, and that's great. Green is still manual. It's more or less the same. And red is what may happen to your test project in the real life. So initial investment, then some kind of plateau, but then it starts growing again. So with live project. And finally, we may end up with a picture like this. This is drawn by me, but it's kind of one of possible outcomes from test automation project. When your automation efforts, which are green in this case, may be higher than total manual efforts. So in this case, your automation is lost in total. You would better stay manual in this case. So what leads to this situation? How to avoid this? This is what we are going to talk. So to understand this difference, this yellow region, we need to consider one test scenario level. So this picture is for test set, for test framework, for many tests. So what happens on individual test case level? So on the manual side, if we look our efforts to deal with specific test case for each iteration is day, maybe agile iteration, it's any kind of periodical time slot that you use to run the test cases. So the efforts required to run manual tests a bit higher in the beginning when you writing test scripts, and then they are more or less equal. So it's more or less constant value. Sometimes a bit more, sometimes a bit less. Maybe application is slower today. Maybe you found some issue and added a defect into the system, so you spent a bit more time. But it's more or less the same. What happens with automation? In the ideal situation that we all want to see, what happens is you have some initial cost to develop the test script, and then you spend no more time with this test case because it's been executed automatically. It's doing validation, and you never get back to it. So you did it once and forgot about it. Unfortunately, in real life, it's happening very rarely, and it's more or less likely that good test case would have the following efforts. So initial investment, then it runs okay. At some iteration, you had, for example, to fix it. For example, something has changed with application, or you found a bug and you had to investigate, or you found that your test case is unstable, so your bit corrected it. Then it runs. Then again, maybe a new version of application has been delivered, and you see that you need to adopt your test case, so you spend some significant time on changing it. But overall, this picture is more or less fine because this minimal test efforts to execute test case, normally they help to get total benefits from having automation in your process. And last case, and unfortunately we see such cases, and they appear all the time. It's Troublemaker, what we call Troublemaker. We developed it once, then next day we were fixing it because it was not performing as we were expected, and we spent even more time fixing it because after first fix something else breaks, then we again fixing it, then application changed, we realized it stopped working at all, and we rewrote it, and it took more time than in the beginning, and anyway it didn't work itself. So this kind of time spending finally leads to more efforts to execute this test case in total than if we were just doing it manually without any automation. This is a troublemaker, and this is what we want to avoid, right? So if we're making a test framework, what we should have, we should have maximum number of ideal test case scenarios. We want to have as much as possible good, but we want to avoid troublemakers because they finally will require too much efforts. We don't need them. They always take our efforts to support them. So then it comes to next question. So how to make this scenario so that it is good or that it is ideal, and how to avoid troublemaker. And here we're going to talk about some characteristic features of text scenarios. So the first is what we call maintainability, and the example is very metaphorical. So you have two cars. Suppose it's a gift for you. So you just need to pick up. You don't need to pay. So you need to take it, right, for your own purpose. So which one would you prefer? You may be a fan of vintage cars. Probably you could take this one if you have a garage. But I think most of us would prefer right one to use it on the daily basis, right? So this answer is evident in this case. However, if we have additional requirement that we pick up it for free, but then we have to use it, and we must maintain it ourselves. So we should be doing all the service work around this car, and it would be used in some unfriendly conditions when it may break. The roads are bad, so it's expected to break. So, and we have to maintain. So which of them is better from maintainability point of view? And in this case, answer is different. For example, if we have damage in the rear window, so which one is easier to repair, this one or this one? Of course, this one is repairable with no problems. You take any piece of glass, cut the square piece, and you have new glass. The engine is on good height. It has two hovers. We may open it and look in it. We may add more water. It's serviceable completely. If something is damaged with the wheel, we would probably see it just from the first glance. So it's known it's 4T, and it's known to be very, very maintainable. It's fixable in any condition. So it's very reliable in this term. Compared to that instance that you can hardly fix it without special equipment, without special knowledge, without special spare parts. In most cases, you may only replace spare part, and you should have it. So it's not so like adoptable in the field when you have nothing and you need to move on. So in this case, what we want to say that test case that cause less troubles, it should be like this one, like left one. So in such situation, you should consider it to be so clear, its construction should be visible from outside. So you should understand how it works. You should see what's broken with it from the first glance. So it's an ideal example of maintainability, and that's what we want to get when we making automated test cases. Next question. So maintainability, okay? We know that we will go for it. Next question, before you started your project. This is very good to know. For example, during the testing, you encounter something like a crash and exception, application failed, it didn't start, page didn't open. So something catastrophic from the workflow point of view that you were going to do with application at this point. So, okay, from one hand, it's good. We found a serious issue. We will write an incident into the tracking system. We found a bug. Okay, that's a problem for developer. They need to fix it. Well, but downside of this issue is, even if you write it to developers, when are they going to fix it? You don't know. And in many cases, they never going to fix it because they may say that crash is not critical. Crashes are really non-critical in many cases. So you will have to live with crash. For example, you deal with some mobile application and sometimes it simply disappears from the screen. What you do is you tap on its icon and it appears back. So it's like a matter of half second. It's not, if it's not too frequent, it's not really annoying. So that bugs may live for years. No one will fix them. So it causes a trouble for automation project because you have this crash, your tests fail, and your test was going to check something, but it didn't reach the point where it was going to check something due to this crash. So it didn't validate what it was expecting to validate or try or check. And it was due to the trouble with application itself, but the trouble in other parts of application appears to trouble for your test case. So this is what you should be aware about, and this is what you should know and keep in mind when you develop the test set. So if crashes are in reality are your problem, which is happening very frequently, so no one will going to fix them for you, then you should design test cases again, simple, stupid, to be able to bypass these issues, to apply workarounds, to not hit the places where this crash happening. So if there is a crash, there should be like a bug or simple test case that reproduces this crash. So your test system is able to find it. But other tests should be able to bypass it and check what they intended to check. One more thing which is good to have is base state. So it's good when test case finds application in some specific state when it starts, and after test ends, it leaves application in exactly the same initial state. It may be some login screen or welcome screen or whatever. So all tests may assume that when they connect to application, it's on this welcome screen, and they should make sure that they return application to this state after they're done. Example is, for example, online pizza ordering application. So you may start an order, add some pizzas to it, and you have to cancel this order in the end, or do checkout and pay. You cannot start new order before you canceled previous order or paid for it, right? So if some test case that's going to order pizza failed or crashed in the middle after opening an order and before closing it, the next test that expects to create new order for some other purpose, it will fail because another order is already created. So it would cause a domino effect and all test set will fail. So what you need is to it's good practice that every test case checks the state of the application, and if it's perfect if you know how to return application from any state to its initial state. And it's better to do it both in the beginning of each test case, just to make sure, are we on initial state? Okay. We are not on initial state. Okay, we return to there. And in the end of each test case. So this is a good practice and it's recommended to have. Next feature of test case. Test script has some length for execution. UI tests are slow. They are known to be slow. They interact with widgets that have some timeouts, some animations, and so on. So what's the difference between having test case that has 1 minute to execute versus a test case that takes 10 minutes to execute? I'm not considering the whole test set execution timeout. It may be really different. Let's consider it from the manual efforts and maintenance efforts point of view. So let's say we need usually from 10 to 20 runs of the test case. It's just average amount, maybe much higher, much lower, but something like that, 20 times run test case while we're creating it. Maybe we recorded it, then we changed some data to be data-driven, applied some variables, added some delays. So, and after doing that, we were executing it to make sure it's doing what's expected, and so on and so forth. So after 20, say, times, the test case appears to be valid. So how much time we spent to develop it? So if it's the test case, it takes 1 minute, so we spent 20 minutes in total for executing it while we were developing it. If it takes 10 minutes, we spent 200 minutes in just executing the test case. It doesn't include in time to write it. So it's 200 minutes, it's 3.5 hours, so it's significant amount of time. And the bad news is, when you have this kind of efforts to develop, you have some similar efforts, you have to spend similar efforts sometimes to fix a test case. When something changes with application, you need to understand what has happened. So you need to fix your test case, run it again, modify to make it proper, because some problems are really tricky, and so on and so forth. So you will again spend time comparable to development time, more or less. So again, you will spend 200 minutes to fix it if you have 10 minutes test case, or you will spend just 20 minutes to fix it. That's completely different efforts. So you should be aware of it when you're developing a test case. So the exception is data-driven test cases. Data-driven usually is something going in the loop, taking data from spreadsheet and feeding to application and checking results. So data-driven test cases may be much longer, and this is not a big issue if you may execute each data line, each row of data alone without executing the whole spreadsheet. In this case, if you have an issue and you may understand what row was causing a problem, and you just take this row, execute, and reproduce the problem. So data-driven test may take like half of an hour as a whole, but one test case may be like less than a minute. So you pick up required data row for looking at report and figuring out which one is failed. And you may deal just with it while fixing your test case. So this is good scenario to follow to have the testing. One more feature is, it's not feature, it's like overall characteristic of test case, of single test case, that I would formulate as test case, ideal test case should be short, it should be simple, and moreover, it should be stupid. Stupid means if you really in rush, if you don't have time, if you forgot how to use it, you should be able to understand how to fix it. Good anti-pattern is regular expression. Sometimes issues of checking some strings are resolved using regular expression. This one on the screen is a very good example. So you normally spend really good amount of time on writing such an expression, and after some time passes, you need the same amount of time just to understand what it is actually mean. And if you may, it's better to avoid using such expressions. If you cannot avoid them, sometimes you have to use them, then wrap them somewhere into like a function or in some place. So this function should be executable alone. So again, you may you need to wrap it into maintainable container, and function is a maintainable container where you may deal with it when you need. Another anti-pattern. Usually, I saw this several times. Usually, when like former developers start doing automation testing, so they see that the form like that, they see, form has a bit 20 objects. Why should I write all these test scenarios? I'm developer, I may do it smarter. I see that automation tool may do like 10 clicks per second, may do 100 clicks per second. So let me just make a great loop and go over these controls in all combinations, enter all different data. I definitely will find some crashes, so my test will be superior and it will test all this application. And what we quickly found, usually in such cases, with such applications, even with mobile application with few items, is that the number of combinations for doing such walk through all the controls grows drastically. It's more than exponential growth. So in this particular case, with 20 controls, the total number of combinations has 18 zeros. So I was just I was googling to find how to call this number. It is quintillion. So the number with 18 zeros. So over 2 quintillion combinations for the form like that. It's absolutely non-realistic to cover such a test case, and it's just one screen. So this approach is like wrong from the beginning. So if you may try to do some more advanced approach like that if everything else is working. Otherwise, don't spend time on it. You may do other more effective things with your application without spending time on these theoretical things. One more typical anti-pattern is redundancy in testing. For example, what we may do, we may check application logs to see that, to make sure no exceptions has been issued. So we may check web service log, we may check application log, whatever application we have. So we may be checking the logs on every script step. So we click the button, we check the logs, we swipe the screen, we check the logs, and so on and so on and so on. So this way we may be sure that exceptions never happen and this application is perfectly running. This kind of like invariant testing, it has a term, invariant testing, is usually applied to very, very mature and stable systems like space, aviation, some medical, and so on. So they are runtime operation systems. They are extremely stable. They are already mature, so you need to get absolute quality from it. Otherwise, for normal systems, this is a redundancy check because, for example, web service log may cause an exception on every step or warning if some time zone is not set on the server, or due to some update is not applied, or some visual theme is not rendered correctly. Users won't even notice this problem. So it's completely a problem of web server or configuration. And the side effect of such approach is that all your tests will fail with such kind of redundancy checking because of this issue. While they will not find any reasonable bugs except this one particular bug about something in the logs. So yeah, you should be careful to avoid such redundancy in your test sets. API dependencies. So if application has APIs, that's always good. We like APIs. APIs allow us to bypass many UI things. UI is slow, API is fast. So that's perfect way to do many things. And we love API. Sometimes we have a choice, which API to use. Some bigger legacy systems have several APIs and some of them overlap in functionality. So my recommendation, check which API is older. In many cases, older means more stable. No one will change it. So you write and you forgot about it. That's awesome result. A good example is Microsoft Exchange. So it has special API called EWS, Exchange Web Services, introduced in 2007. It's so based interface. Since Microsoft Office 365, they also introduced REST interface, but it's still changing. So what we know about this old SOAP interface, that million of instances of Outlooks do rely on this interface because Outlook is using it. So they will really hardly ever do any undoable changes to it. So we may completely rely on it for the significant time in the future. While the REST API, they may decide that it's something still experimental. If they see it's not really used, they may decide to change it for something else. So this is something less stable from this point of view, from today's point of view, than SOAP version. So that would be, for me, that would be a final factor to decide which one to use. Now let's climb up onto the test set level. So we talked about features of particular test case or test scenario. So suppose we more or less aware of that, and we understand how to write them. So what we should be aware about test set level? That's very important understanding. First thing to check is system deployment. In many examples, when we read about DevOps, what we see is you click one button, application is completely built and deployed, and you have new instance that you may use for running tests. So this is good example, but in reality, I saw maybe one or two such applications in real life. It's good for when you are something like GitHub who developing such an application, who invented DevOps. But in real life, you have third-party controls, you have complicated deployment, you have external dependencies, you have external web services, you have packaged application like Microsoft Dynamics, or you have combination, some CRM system with some accounting system, you somehow link them together, and this is your solution that you are developing. So you have the development itself, the deployment itself may take hours. So it may be hours to just deploy. So no one will have new fresh instance for each build, for example. Even you will, in some cases, you have only one staging instance and one production instance and nothing else. So all the test cases should work with single staging instance. In the worst case, you don't even have staging, you deploy to the production, this also happens. So any combination is possible. So if you deploy to production, you should be able to run tests quickly to see that everything is working, or you maybe need to roll back latest changes and fix them. So this is very important thing that would change your tactics on how to run tests, on how to develop tests, and what feature they would cause. Quick execution, a full execution, depth of the checks, or what you may rely on, or what you should skip from because it doesn't depend on you, and so on. One more thing is virtual machines. Again, it's a tricky topic. Some organizations have, sometimes you take virtual machines from outside, from clouds, but some organizations prefer to host them internally. So you have some kind of server running several virtual machines. So and some of them are dedicated to testing. So your tests are executed on these virtual machines. So what's happening is that you have server, you have few virtual machines on this, you're running tests. But this server may have other virtual machines doing something else. And these other virtual machines have own tasks, and sometimes they have to do some really heavy tasks, like building something, like upgrading something by downloading. So they may take network bandwidth, they may take computation power. So you're running your test and other virtual machine doing its own heavy job, and it actually affects the results of test case execution. So it's part of an environment you should be aware of. So it's better for you to either own this VM server to know what's happening on it, or to have good communication to owner of this server and to know exactly what else is happening on it when you run test cases. So if you have any issues, you should know what other things may cause the performance of your test cases. One more thing was to have, when you develop a test set, is sanity checks. So suppose you have a system in some intermediate state, like database connection is broken. You run 100 test cases, and each of them will fail one after another, because nothing is working while database connection is broken. In this case, it's good to have some very short, very quick test case doing these checks. So quickly check database, quickly check some common functionality, quickly check the system status or system version. One thing from my life, I saw this several times. Quickly check disk size everywhere, on the machine running the tests, on the machine running the application. Never hurts, because logs, everything is the disk space, and it's usually, this is last thing you will check yourself when you have an issue. So if you have this quick check, it may take just a matter of seconds to validate everything, and it may signal you that system is not ready for test execution. All your tests will fail. So instead of waiting for hours for all tests to fail, you know that they will fail in like a few seconds, so you may quickly fix something and not waste these hours. One more factor that affects the quality of test cases is maturity. Maturity is how stable the system, the whole system, or some part of the system. For example, one part may be stable and stay the same for years because it's old, it's rarely used, and while another part may be under active development, and it may have changed UI, changed interfaces, changed control every few weeks, because it's something developed under pressure of external requirements. So the more mature system, the more mature part we deal with, the more fine-grained and meticulous testing we may do with it. Otherwise, if system is rapidly changed, we should stay testing it manually, or make unit tests, or apply some smart type of testing that is able to bypass changing nature of the specific part of the script. I mean, it's good to know which part of application is stable, or if whole application is stable and which is not, and put adequate reports. Don't try to test everything deeply, because these changing parts will cause problems to you, because execution will fail time after time. Data feeds, also important part. So, okay, we have automation test. We need to feed some data to the application to execute. So if we need to check search functionality, we need to feed data inside application to be able to search for it. So what we may do, we have data feed, we have some script doing it. It may import this amount of data very quickly. So we may just generate some really random data. We may, for example, for CRM system, we may put 100,000 contacts into it and then work with that system. That's possible, and that's typical. Then you generate it quite randomly. The whole execution of such kind of test, you will find maybe one issue due to generated data, or no issues. And the whole system became slow because too many data. Search is slower, disk consumption bigger, logs are bigger, harder to find something, and so on and so forth. In contrary, it's possible to make much shorter data set manually and go over the corner cases. For example, if it's contact, you should make contact with first name, last name, another contact with few intermediate names, another contact where first and last name changed in the sites. So things that some contacts with like German letters like Umlaut and so on and so forth. So, and when you go over this combination that usually cause problems, you may come up with maybe 50 entries or maybe 100 entries, not much more. So you have much smaller data set, but usually such kind of data set is able to find really more issues than 100,000 of randomly generated issues. So good data is a halfway to success. So dealing with good data helps you to have much faster and much more effective test cases. There are known scenarios and known approaches to testing that are worth knowing about. First is security testing. We published a few articles about security testing with Rupees. We use it for our own Spira products. Also, we implemented public test framework for security testing. It's available on the GitHub. Not here. It's available on the GitHub, and we have a link to it here. So security testing is a way to, it's well-established, well-known approach on how to test permissions for modules. If your application is modular and each of them have access control lists, sometimes, and application have roles, then it's a good approach to have few spreadsheets specifying available modules, available roles, you see, available role permissions, and available users with their roles. So the test set may go over these spreadsheets and check all these combinations and availability and presence or absence of some menu items depending on current user's role. So again, it's one of the patterns that's well established. So when we are going from one application to another similar application, we may take it as a whole, modify the spreadsheets, modify just a few objects, and it will be applicable. So that's an effective way of developing test cases. Another common testing concept is load testing. Very important to know when to use it, because we still hear the questions. So we have like UI test. We need to check that this UI test works in parallel for 50 users or for 100 users. And what people try to do, they try to set up Selenium grid, run 100 instances, and to check that application works as expected, for example. We don't recommend doing this. It's not effective way, because even if you have Selenium grid and you want to have 100 users executing the tests, this would mean you need 100 cores working in parallel, and 100 cores would be really expensive, computational equipment that you will have to purchase or allocate, and moreover, the results of such testing are not really sufficient. What you will get, you may spend more time dealing with issues related to Selenium breed itself rather than to find problems with application. That's why there is load testing for such cases. It's always wrong to try just use UI test for these kinds of testing. Just a quick metaphor: you may have one node, just one core with load test to mimic thousands of users, not 100 cores for 100 users, but one core for thousands of users. You may have things like synchronization points and ramp ups. So all users, for example, pre-fill form data and click on the login button at the same time to have peak load on the server. Many such awesome things. Load testing tool will collect the feedback from the server to see what the peak load, what was memory consumption, and so on and so forth, what was errors and so on. So Rapis has integration with NeoLoad. You may find some webinars on our channel about that. And this is pattern and recommended way to do testings like that. And doing it UI way, again, is a means concept and anti-pattern. So when you have continuous integration, you try to execute tests for each commit or daily or whatever as a part of your process. So what you need to know, that CI is expected to be unattended. You commit and you just wait. You don't see where it's happening. So you may have simpler tests, you may have deeper tests. What you need to know, that not all tests should be executed as a part of CI. So you need to select those that are really designed for unattended execution. For deeper tests, for load tests, for some validations, you may better have another schedule not related to these continuous integration commits. So you execute them weekly, execute them like daily in the night, and so on. So it's good to understand that not all tests must be run for each test execution. And now, very short example. So probably you want example. Let's consider real life test framework. It's some kind of CRM system, and it will demonstrate how we do recommend to design your test case and test frameworks and test cases. So suppose that you have some CRM. It has a number of modules: leads, contacts, account, quotes, orders, products, administration, and dashboards. And the functionality is more or less similar for each of these modules. You see it in the left. So what we have here is grid-like structure. So the first thing we did before doing the test framework, we make a picture of functionality that we want to cover with our test framework. In this case, it's grid. Sometimes it's just a list. Sometimes it's tree-like structure. But it's good to have not just set of use cases, requirements, documentation, or stories. It's good to have exact list of things you want to be covered by test framework. So in this case, each cell in this grid is something we want to cover. Let's consider typical manual tests. So manual test for CRM is to promote lead. So we log into the system, we have some lead in mind. So we first pass securities, so we have access to leads model. That's why we see it. Then we do search if the same lead is already in the system. If it's not here when we enter this lead, then once lead is there, that typical flow for lead is to promote it. So once while we communicate inside of CRM, we may make contact from the lead and account, and so we promote lead, and two entries should appear, contact and account. Also, it should make sure that account, the company name, is not yet in the system. So again, search for accounts will be applied. So, and two entries will be added. In addition, when promoting, we are adding address and billing information for account and for contact, so we're editing them, and then reviewing that everything is okay. And finally, we are deleting the lead. So this is what is usually done by user when promoting a lead. So, and I just marked the pieces of functionality inside the system that are covered by this manual test case. It's reasonable to have test case like that for manual because it has some sense, because we don't, it covers quite a significant range and functionality in one step. We log in only once, and so this is reasonable manual test scenario. But for automated test set, I would recommend to have test cases like here. So we just log in and we just test search and nothing else when we log out, or we just log in and create lead, make sure. But you see difference between 1V and 3V. When we logging in, we don't validate in login. We just using it as functionality with minimal number of checks. And here in the search, we test it properly. We test it to deeper level than we do it here in the manual test. And again, another test case may test create functionality, another test case may test edit functionality. So with automated test set, we don't try to save time to do login. We are not so lazy. We are not doing it manually. So let system do login, log out every time. Let it have this simple, stupid test case with touching minimal other parts of the system while testing this part of the system. That would make it much more maintainable than in the case like here. So wrong concept is to try to just implement this scenario, because if something is broken in the initial stage, in the search, for example, if search is not working right now, so it would fail to validate other parts like creation, edit, and so on. So it would again cause this domino effect, and it will affect maintainability of the whole test set. So that's why we recommend to do this way. If you know good patterns like security testing, then of course you may use that. So with security test framework, like I shown you a bit earlier, you may see that we cover the whole line of security for all modules just in one loop in the same data-driven test. One last thing, when designing a test set, it's good to know in advance these gray zones. The gray zone means that something is not really stable in the system. It's not working properly, or it's actively changing, and it is under active development, so it will change with its iteration. So when planning what to scenarios do first, what to do then, it's better to first cover these white parts and try to avoid these gray parts. If you don't know, if you're still in exploring the system and you see that's you have feeling that what you're trying now is gray, it has some intermittent nature, it's better to skip it. Keep running some test cases manually and find white places and implement them first. The reason is, from the day one, when you have automated test case, it's useful. So it's involved in some daily execution. So it starts saving your time. It starts saving your cost. So if you skip these gray ones, that would cause you troubles. And first cover these white ones. They will release enough time to spend more effort on covering these gray lines. So tactically, it's more correct to first do some basic testing to find out these gray zones and white zones, then complete the testing of white zones, and only then return to gray ones. So I'm summarizing. For test case level, Just simple rule. The test case should be simple, short, and stupid, like 4T. For test set label, test set label should be smart, well thought, tactically correct, reasonably combined, and so on. So test set should be, test set is something that you should think about many times on how to properly develop it, and it will bring you results. While thinking about test sets, good to be aware about key reasons on how to deal with particular test case. You need to be aware about gray areas, which are unstable things, about maturity of different types of different places in the system, about crashes, potential crashes or known crashes, and about requirements of what you really need to test or what you like to test. So that's it. That's end of my speech. We will see you next time in 2 weeks, and I'll be telling you about, we will talk about AI. We will talk about AI. It's time to talk about AI. Everyone is talking about AI, so we're also going to talk about it. In AI in testing. This is the topic of the next webinar. So thank you for attention.
Thank you, Alexei. I just want to wrap it up by saying that our next webinar is scheduled for Thursday, August 7th at 10 a.m. Eastern. And it will be, like Alexei mentioned, about AI, and it's AI in test automation. I will send the recording of today's webinar and the link to next webinar in the same email, so please be on the lookout. Thank you again for joining us today, and I hope you have a great week. We will see you soon.